Greetings, young historians. Welcome to another of our AP World History guided reading sessions. We will again be reading from our textbook, The Riveting the Earth and Its Peoples. We are on chapter 24, and we are starting on section 2, the technological revolution of the Industrial Revolution, which is our topic at hand. As usual, I advise you to take notes. 5 revolutionary innovations spurred industrialization. 1. Mass production through the division of labor. So, we talked about this in class on Tuesday. Everyone has a task, and they are responsible for that task, and that allows you to produce something faster. It's the precursor to the assembly line. 2. New machines and mechanization. So, they build things that do it better. A great increase in the supply of iron. 4. The steam engine and the changes it made possible in industry and transportation, which we also talked about today, being able to move your product. And 5. The electric telegraph. Interesting. This is going to provide the ability to communicate. The pottery industry offers a good example of mass production, the making of many identical items by breaking the process into simple, repetitive tasks. East Asian potters had long known how to make fine glazed porcelain or china. In Europe, before the mid-18th century, only the wealthy could afford fine porcelain, which was imported from Asia. Middle-class people used pewter tableware, and the poor ate from wooden or earthenware bowls. Several royal manufacturers, Meissen in Saxony, Delft in Holland, and Sèvres in France, were founded to produce exquisite handmade products for the court and aristocracy, but their products were much too expensive for mass consumption. And we talked a little bit about this idea today that if you make something by hand, if it's a cottage industry, if it's something that takes a long time to put together, your time is valuable, so that's going to contribute to the cost. Meanwhile, more and more Europeans acquire a taste for tea, cocoa, coffee, and wanted porcelain that would not spoil the flavor of these hot beverages. Spoiled. This demand created opportunities for inventive entrepreneurs. Britain, like other countries, had many small pottery workshops where craftsmen made a few plates and cups at a time. Much of this activity took place in a part of the Midlands that possessed good clay, coal for firing, and lead for glazing. There, Josiah Wedgwood opened a pottery business in 1759. Today, the name Wedgwood is associated with expensive, highly decorated china. But Wedgwood's most important contributions lay in producing ordinary porcelain cheaply by means of the division of labor. So it is Wedgwood who's come up with this idea of giving each person a specific task. And my boxer has chosen this moment to play with her squeaky toy. That's helpful. To do so, he subdivided the work into highly specialized and repetitive tasks, such as unloading the clay, mixing it, pressing flat pieces, dipping the pieces in glaze, putting handles on cups, packing kilns, and carrying things from one part of the plant to another. He substituted the use of molds for the potter's wheel whenever possible, a change that not only saved labor, but created identical plates and bowls that could be stacked. Wedgwood was also interested in new technologies. He invested in toll roads and canals so that the clay could be shipped economically from southwestern England to his factories in the Midlands. So if you cut the cost of transportation, you increase profit. In 1782, to mix clay and grind flint, he purchased one of the first steam engines to be used in any industry. These were radical departures from age-old methods of craftsmanship, but the division of labor, strict discipline, and the new machinery allowed Wedgwood to lower the cost of his product while improving the quality, and to offer his wares for sale at lower prices. His factory grew far larger than his competitors' factories and employed several hundred workers. His own salesmen traveled throughout England touting his goods. Wedgwood's interest in applying technology to manufacturing was connected with his membership in the Birmingham Lunar Society, a group of manufacturers, scientists, and inventors who met when the moon was full so they could see their way home after dark. No streetlights. This critical mass of creative thinkers, willing to exchange ideas and discoveries, encouraged the atmosphere of experimentation and innovation that characterized late 18th century England. So, in the Enlightenment, we talked about French thinkers meeting at the Salon to talk about their intellectual ideas, a think tank, if you will. And so now industrialists are doing the same thing. Let's meet and sort of compare notes and brainstorm and see what we can come up with as a group. Similar societies throughout Britain were creating a vogue for science and giving the word progress new meaning. Change for the better. So science was cool. The cotton industry was the largest industry in this period. The cotton industry, the largest industry in this period, illustrates the role of mechanization, the use of machines to do work that was previously done by hand. Cotton cloth had long been the most common fabric in China, India, and the Middle East, where it was spun and woven by hand. The cotton plant did not grow in Europe, but the cloth was so much cooler, softer, and cleaner than wool that the wealthy Europeans developed a liking for this costly import. Stop. Why is it a costly import? It costs a lot of money to prepare cotton because it has to be picked by hand and the seeds have to be removed from it by hand. Now, mind you, in a lot of places in America, this was being done by slave labor, but there's still costs associated with that as it's the plantation owner's time. So it made cotton more expensive during that period. When the powerful English woolen industry persuaded Parliament to forbid the import of cotton cloth to England, it stimulated attempts to import cotton fiber that made the cloth so the cloth could be made locally. So people were not people in Europe were not importing raw cotton. They were importing finished fabric, which was even more expensive than raw cotton. Here was an opportunity for enterprising inventors to reduce costs with labor-saving machinery. To turn inventions into successful businesses, inventors had to link up with entrepreneurs or become businessmen themselves. Making a working prototype often took years or even decades, and many inventions led to dead ends, which is still true. A great number of inventions don't make it at all, or they end up as seen on TV, and they don't make any money, but there's always that one thing that can make you rich. History remembers the successful, but even they struggled against great odds. Beginning in the 1760s, a series of inventions revolutionized the spinning of cotton thread. The first was the spinning jenny, which we looked at in class today, invented in 1764, which drew out the cotton fibers and twisted them into a thread. So remember from the photo, the steam powered the wheel, which drew in the fibers and twisted them into thread. The jenny was simple, cheap to build, and easy for one person to operate. Early models spun 6 or 7 threads at once, later ones up to 80, so you make it bigger and it can pull more. The thread, however, was soft, irregular, and could only be used in combination with linen. In 1769, so 9 years later, Richard Arkwright invented another spinning machine, the water frame, which produced thread strong enough to be used without linen. Arkwright was both a gifted inventor and a successful businessman. Great combination. His machine was larger and more complex than the jenny, which required a source of power such as the water wheel, hence the name water frame. To obtain the necessary energy, he installed many machines in one building next to a fast-flowing river. So he's going to use the current of the water to spin his wheels. The resemblance to a flour mill gave such enterprises the name cotton mill. In 1785, Samuel Crompton patented a machine that combined the best features of the jenny and the water frame. This device, called a mule, produced a thread that was strong enough and fine enough to be used in finer qualities of cotton called muslin. The mule could make a finer, more even thread than any human, and at a lower cost. Now, British industry could undersell high-quality handmade cotton cloth from India. Bam! You no longer have to import the goods, therefore they are cheaper, and people will buy them. As a result, British cotton output increased tenfold between 1770 and 1790. We looked at the statistics on that today. If you weren't in class, they were pretty shocking. They went from about 2 million pounds of cotton to, by the year 1790, 360 million pounds of raw cotton. Crazy! The boom in thread production and soaring demand for cloth created bottlenecks in weaving. Inventors in England rose to the challenge. The first loom was introduced in 1784, but was not perfected until after 1815. A loom takes these threads and puts them all together. Other inventions of that period included carding machines, chlorine bleach, and the cylindrical printing presses. We didn't talk a lot about the printing press, but the original printing press was blocks of print that pushed down on the text. The cylindrical printing press has the letters on a wheel, and so you can turn the wheel in the die and then onto the paper to imprint what you want to say. By the 1830s, large English textile mills powered by steam engines were turning raw cotton into printed cloth. Ooh, so you can put fancy stuff on it. This was a far cry from the cottage industries of the previous century. Cottage industry, we talked about that today. We think of it as, I'm selling something in my cottage. It's handmade goods in your home. Mechanization offered two advantages. One, productivity for the manufacturer. So productivity, if you're not clear, is the ability to make more at a quicker rate, thereby increasing profit. And two, price for the consumer. So I can offer it to you cheaper and still make money. And because mine is cheaper, more people will buy it, so I'll make even more money. Whereas in India, it took up to 500 hours to spin a pound of cotton, the mule of 1790 could do in 3 person-hours, and the self-acting mule, which is an improved version in 1830, could do it in 80 minutes. 500 hours or 80 minutes? You pick. Cotton mills needed very few skilled workers, and manufacturers often hired children to tend to the spinning machines. Ooh, okay. Why are we hiring children? 1, they're cheap. 2, they have little fingers, and the spinning machines had little parts. So you want somebody with very small fingers who can untangle what's going on in your machine. The same was also true of power looms, which gradually replaced the hand loom for weaving. The number of power looms rose from 2,400 in 1813 to 500,000 by 1850. Meanwhile, the price of cloth fell by 90% from 1782 to 1812 and kept on dropping. So you can buy the stuff even cheaper than before, but people are still making a ton of money off of it. Awesome, right? What could possibly go wrong? The industrialization of Britain made cotton into America's most valuable crop. Uh-oh. Who's going to pick that cotton? In the 1790s, most of Britain's cotton came from India, as the United States produced a mere 750 tons of mostly long staple cotton from South Carolina. In 1793, the American Eli Whitney patented his cotton gin, a simple device that separated the bolls from the fiber and made the growing of short staple cotton economical. This invention permitted the spread of cotton farming into Georgia, Alabama, Mississippi, and Louisiana, and finally as far west as Texas. By the late 1850s, the southern states were producing millions of tons of cotton a year, 5/6 of the world's total, and they have an endless supply of free labor. So great. With the help of British craftsmen who introduced jennies, the spinning jennies, mules, and power looms, Americans developed a cotton industry in the 1820s. Stop. Okay, they are not producing cotton fabric. in America at this point. I want to make this clear. The Industrial Revolution is not happening in the United States right now. They're producing the raw material that England is then transforming into the product that is sold. That's an important distinction because it's going to take a while for America to hit its Industrial Revolution. It's going to come to the show a little late. By 1840, the United States had 1,200 cotton mills, 2/3 of them in New England, and they were powered by water rather than steam. So they do this with the help of the British, but it's not to the same extent. It's enough to supply the country so they don't have to import these products, but they're not the exporter that Britain becomes through mass industrialization. Iron is also transformed during the Industrial Revolution. Throughout Eurasia and Africa, iron had been in use for thousands of years for tools, swords, and other weapons, and household items such as knives, pots, hinges, and locks. In the 11th century, during the Song period, Chinese forges had produced cast iron in large quantities. Production declined after the Song, but iron continued to be common and inexpensive in China. Wherever iron was produced, however, deforestation eventually drove up the cost of charcoal, which is used for smelting, and restricted output. So in China, in order to make iron, you need fire, and in order to make fire, they did not have coal, like they do in Great Britain, and so they had to use lumber, which meant they cut down all of their trees. So there we have theme, environment. Furthermore, iron had to be repeatedly heated and hammered to drive out impurities, a costly and difficult process. Because of limited wood supply and the high cost of skilled labor, iron was rare and valuable metal outside of China before the 18th century. A major breakthrough occurred in 1709 when Abraham Darby discovered that coke, not coke, but coke is in the coal which has had the impurities cooked out of it, could be used in place of charcoal. The resulting metal was of lower quality than charcoal iron, but was cheaper to produce. Because, like we have talked about for 2 days, coal is very plentiful and easy to access in Great Britain. In 1784, Henry Court found a way to remove some of the impurities in coke by puddling, which is as it's cooking, you stir it with these long rods, and it produces a more refined product. It has less flaws in the finished metal. By 1790, 4/5 of all Britain's iron was made with coke. Other countries still used charcoal. Coke iron was cheaper and less destructive of forests, and it allowed a great expansion in the size of individual blast furnaces, substantially reducing the cost of iron. There seemed almost no limit to the quantity of iron that could be produced with coke. Britain's iron production began rising fast, from 17,000 tons in 1740 to 3 million tons in 1844, as much as in the rest of the world put together. In turn, there seemed no limit to the amount of iron that an industrialized society would purchase, or the novel application for this cheap and useful material. Novel application, so I've discovered there's something that I can use to make things. I will now dream up any possible use for this if it gives me a product to sell. It's like the pet rock. In 1779, the iron manufacturer Abraham Darby III, who is the grandson of the guy that came up with this process, built a bridge out of iron across the Severn River. In 1851, Londoners marveled at the Crystal Palace, a huge greenhouse made entirely of iron and glass and large enough to enclose the tallest trees. The idea of interchangeable parts originated in the 18th century, when French army officers attempted, without success, to persuade gunmakers to produce precisely identical parts. The craftsmen continued to use traditional methods to make gun parts that had to be fitted together by hand. So, prior to having a mechanized way to make metal parts, people are hammering them out, and this part only fits on the gun for which it was made. So if that part of your gun breaks, you have to have another one made specifically for your gun. That's convenient if you're out in the middle of battle in the field in nowhere, and the guy that made your gun isn't handy. By the mid-19th century, interchangeable parts manufacturing had been adopted in the manufacture of firearms, farm equipment, and sewing machines. At the Crystal Palace exhibition of 1851, Europeans called it the American system of manufactures. In the next 100 years, the use of machinery to mass-produce consumer items was to become the hallmark of American industry. So, America finally, towards the mid to late 19th century, start to catch on. We need to get on the boat. Although mechanization of manufacturing was very important, the most revolutionary invention of the Industrial Revolution was surely the steam engine, a mechanical substitute for human and animal power, as well as wind and water power. By the late 17th century, many activities were experiencing serious bottlenecks because of lack of energy. Pumping out all this product, but a guy in a boat that depends on the wind to blow it where it needs to go is trying to deliver it, and it's not going to get there very fast because the wind isn't going to blow him there very fast. In particular, deep mines filled with water faster than horses could pump it out. So here we have coal miners trying to mine, and it's very rainy in Great Britain. It's a wet place, and so their mines fill with water, and if they want to get it out of there, they got to do it a bucket at a time. Scientists understood the concept of atmospheric pressure and had created experimental devices to turn heat into motion, which I hope you understand that concept by now, but they had not found a way to put those devices into practical use. Then, between 1702 and 1712, Thomas Newcomen developed the first practical steam engine, a crude and inefficient device. Its voracious appetite for fuel mattered little in the coal mines, where fuel was cheap, but it was too costly for other uses. So the very first one of these engines, you gotta feed that sucker coal all the time to get it to run. So it's not going to be economical for someone who's trying to run a loom to be pumping coal into it all day. But at the coal mine, where there's coal, it was fine. James Watt, an instrument maker at Glasgow University in Scotland, was asked to repair the university's model Newcomb engine. So the school had a model to show students an example, and this guy was asked to repair it when it broke. Watt realized the engine wasted fuel because the cylinder had to be alternately heated and cooled. So an engine, in order to produce power, has to have motion, and the cylinder spins, and that energy causes it to get hot, and if you don't want the machine to catch on fire, you have to cool it off, which is true of any engine, even now, which is why we have antifreeze in our cars, and if you were, unfortunately, on the recent Carnival cruise ship, their engine started on fire as a result of not being cooled. He developed a separate condenser, a vessel into which the steam was allowed to escape after it had done the work, which left the cylinder always hot and the condenser always cold. So heat leads through a specific place and therefore doesn't heat parts of the engine that don't need to be hot. He patented this idea in 1769. He enlisted the help of the iron manufacturer Matthew Boulton to turn his invention into a commercial product. In 1785, Boulton and Watt began selling steam engines to manufacturers of iron, pottery, and cotton. This paragraph mentions the patent sort of in passing, but I think it's an important thing to note that people are putting their stamp on their ideas and registering them with the government and saying, this is mine, I invented it, I came up with this idea, because it's intellectual property and you don't want someone to copy you and make profits from your work. Watt's steam engine was one of the most celebrated inventions of the 18th century. Because there seemed almost no limit to the amount of coal in the ground, steam-generated energy seemed an inexhaustible source of power, and steam engines could be used anywhere that animal, wind, and water power were lacking. Without the steam engine, industrialization would have been a limited phenomenon. Inspired by the success of Watt's engine, inventors in France in 1783 and in the US in 1787, and in England in 1788, put steam engines on boats. The need to overcome great distances in the United States explains why the first commercially successful steamboat was Robert Fulton's Clermont, which steamed between New York and Albany in 1807. And the steamboat will become the method by which all this cotton is carried down the Mississippi or up the Mississippi to places where it can then be shipped out. Soon, steamboats were launched on other American rivers, especially the Ohio and the Mississippi, gateways to the Midwest. In the 1820s, the Erie Canal, which is up north in New York, linked the Atlantic seaboard with the Great Lakes and opened Ohio, Indiana, and Illinois to European settlement. Why European settlement? Because Canada's on the other side of the Great Lakes. There's a little geography lesson for you. Steamboats proliferated west of the Appalachian Mountains by 1830. Some 300 plied the Mississippi and its tributaries. To counter the competition from New York State, Pennsylvania built 1,000 miles of canals by 1840. The U.S. was fast becoming a nation that moved by water. Ocean-going, steam-powered ships were much more difficult to build than riverboats. For the first steam engines used so much coal that no ship could carry more than a few days' worth. You got to carry your fuel on board and still have room for passengers or cargo, or both. The Savannah, which crossed the Atlantic in 1819, was a sailing ship with an auxiliary steam engine that was used only for 90 hours of its 29-day trip. Interesting. So at times when the wind doesn't propel you, you use the engine, and when the wind is in your favor, you turn the engine off. But soon engineers developed more efficient engines, and in 1838, two steamers, the Great Western and the Sirius, crossed the Atlantic on steam power alone. Elsewhere, sailing ships held their own until late in the century, for world trade was growing so fast that there was enough business for ships of every kind. If you have a ship, you got stuff to put on it. People and cotton and slaves and you name it. On land, as on water, the problem was not imagining uses for steam-powered vehicles, but building ones that worked, for steam engines were heavy and weak to pull any weight. After Watt's patent expired in 1800, inventors experimented with lighter, more powerful, high-pressure engines, an idea Watt had rejected as too dangerous. By the way, steam engines were very dangerous, and they would explode, so it's an interesting side note. In 1804, the engineer Richard Trevithick built an engine that consumed 12 times less than Newcomen's and 3 times less than Watt's. And with it, he built several steam-powered vehicles that were able to travel on roads or rails. Horses could pull heavier wagons on wooden or iron rails better than on cobblestone roads. But what if I can get a horse that's powered by an engine? Like horsepower. By the 1820s, England had many horse-powered railways. One of them, the Stockton and Darlington Railway. The chief engineer, George Stephenson, began using steam locomotives in 1825. 4 years later, the owners of the Liverpool and Manchester Railway organized a contest between steam-powered locomotives and horse-drawn wagons. Stephenson and his son Robert easily won the contest with their locomotive, the Rocket, which pulled a 20-ton train at up to 30 miles per hour. Yeehaw! After that triumph, a railroad building mania lasted for 20 years that swept through Britain. The first lines linked towns and mines with the nearest harbor or waterway. In the late 1830s, passenger traffic soared, and entrepreneurs built lines between the major cities and then to small towns as well. Railroads were far cheaper, faster, and more comfortable than stagecoaches, and millions of people got in the habit of traveling. I don't know if you've ever noticed, but horses don't always smell so good. And if the wheel breaks on your stagecoach in the middle of nowhere, it's a real bummer, dude. You're not going to be able to call AAA to come and fix it. In the United States, entrepreneurs built railroads as fast and cheaply as possible with an eye to quick profits, not long-term durability. Ooh, sound familiar? So I want to make money, but I don't really care if it breaks. By the 1840s, 6,000 miles of railroad track radiated westward from Boston, New York, Philadelphia, Baltimore, and connected those cities to one another. The boom of the 1840s was dwarfed by the mania of the 1850s, when 21,000 new miles of track were laid, much of it westward across the Appalachians to Memphis, St. Louis, and Chicago. By the way, all of this rail is being built by Chinese laborers who are not being paid very well. After 1856, the trip from New York to Chicago, which once took 3 weeks by boat or horseback, could be made in 48 hours. More than anything else, it was the railroads that opened up the Midwest, turning the vast prairie into wheat fields and pasture for cattle to feed the industrial cities of the eastern United States. So you can grow things in the heartland and then get them to the coasts via rail without them spoiling, because you can do it in 2 days instead of weeks. Railroads triggered the industrialization of Europe. Belgium, independent since 1830, quickly copied the British. In France and Prussia, the state planned and supervised railroad construction from the start. So here we have in France and in Prussia, the government's doing this instead of private industry, and that's going to have a negative effect. This delayed construction until the mid-1840s, because they had to come up with the money, for one thing. When it began, however, it had a greater impact than in Britain, for it satisfied a long-standing need for transportation and stimulated the iron machinery and construction industries. Abundant coal and iron ore deposits determined the concentration of industries in the swath of territories running from northern France through Belgium and the Ruhr district of western Germany to Silesia in Prussia, which is now part of Poland. Some of you asked me what happened to Prussia, and the answer is it's diffied up. In 1850s and 1860s, the states of Germany experienced an industrial boom, as well as France and Belgium. So Great Britain, clearly the first, and then their neighbors follow, and the United States is kind of tiptoeing along, and closer to the end of the 19th century, the U.S. will break into it big time. Communication over the wires. Here we go. The advent of railroads coincided with the development of the electric telegraph. After the Italian scientist Alessandro Volta invented the battery in 1800, making it possible to produce an electric current, many inventors tried to apply electricity to communication. The first practical telegraph systems were developed almost simultaneously in England and America. It's interesting. In England, Wheatstone and Cooke introduced a 5-needle telegraph in 1837, and it remained in use until early in the 20th century. That same year, American Samuel Morse introduced a code of dots and dashes that could be transmitted with a single wire. Morse code, I'm sure you have heard of it. So the Morse code operator has a little thing that taps on the wire, and the length of his tap, so this is a dot and that's a dash. And there's a series of codes that you would type, and each one corresponded with letters of the alphabet or numbers. A line was erected between Washington and Baltimore. By late 1840, telegraph wires were being strung throughout the eastern and western throughout the eastern United States and Western Europe. Not the Western United States. It's still the Wild West. In 1851, the first submarine telegraph cable was laid across the English Channel from England to France. So they lay this in the water. It was the beginning of a network that eventually enclosed the entire globe. So now I don't have to wait for my letter to get there. I can send a message immediately. The world was rapidly shrinking to the applause of Europeans and Americans, for whom speed was a clear measure of progress. No longer were communications limited to the speed at which a ship could sail or a horse could gallop. We can talk to each other. We can spread ideas even faster. Alright, so that's the end of that section. Join me for the next section, which will be the impact of the Industrial Revolution. Dun, dun, dun. There's good news and bad news, and I look forward to seeing you then.